bonding flashcards. Again, I've got my phone and I've got the specification here. No, that's atomic structure, which you've already gone through. I don't know if it's posted by now. Ionic bonding, formula designs, construct formulas for ionic compounds. Yep, coordinate bonds. Multiple bonds contain multiple pairs of electrons. Represent covalent bond using a line, coordinate bond using an arrow. There is absolutely no mention of molecules. Shapes of simple molecules, yes, but they never have mentioned. I forgot how much bonding is. Yeah, but they've never mentioned about defining a molecule. So you don't need to know that. But when a molecular substance turned into a gas, only intermolecular forces overcame, not the bonds. I think that's really important. That is very important. So I might write that down on this whiteboard. And this is the observations of the period 3 elements, which I do need to memorize as well. Great. Not deep bonds. A key factor in molecular substance turns into a gas. Also, guys, if I do get an A star in A-level chemistry, I think I might even do some, tuition, because I will tell you guys about my story then, if obviously I get it. Inshallah, I do want to get results here, but it's all up to God. Not in my hands. All I can do is put in the work. God controls everything else, and God allows me to do that work. But if I do, I will share you guys with my story, why I came up with this channel, what grade I've came from, like what grade I had previously to what I've achieving, and all of that. And I think it'd be very motivational. And also, I actually think generally for this exam board AQA, I think I could help a lot of students. Hydrogen bonding definition: an attraction between an electron deficient hydrogen atom of one molecule and lone pair of electrons NOF on a neighboring molecule. Attraction between electron deficient hydrogen atom one molecule and neighboring a lone pair of electrons NOF on a neighboring molecule. Just like with thermodynamics, there are just definitions you just have to memorize. Non-polar molecules have small temperature dipoles. When you boil a liquid, we need to overcome intermolecular forces so particles escape from liquid surface, and physical properties, van der Waals effect, viscosity, or melting point. Okay, let me just have a look at the textbook for bonding. Carry on. Key difference of shapes of molecules, van der Waals forces. Long straight molecules are closer together than branch chains. They have a strong force between them, and larger molecules have larger electron clouds. You do need to know this. Do need to know this. 2 key characteristics of iodine. You might think you don't need to, but you do. In the specification, it wants you to know the structure of graphite, diamond, sodium chloride, or iodine or magnesium. One of those. But it could ask you on those. So iodine, you do need to know some characteristics of it. The atoms are held in pairs by strong covalent bonds forming iodine molecules, and the molecules are held in a molecular lattice by weak van der Waals forces. So you can see the contradiction. The atoms are held by strong covalent bonds, but the molecules are held by weak van der Waals forces. I think that's why it's on the specification, to show you that contradiction. 3 types of intermolecular forces, obviously you should know this. Induced dipole-dipole, van der Waals, permanent dipole-dipole, or hydrogen bonding. And iodine is solid at room temperature. It's a key fact. You don't need to know that. Intermolecular forces are much weaker than covalent, ionic, and metallic. That's very important to know. Key fact about molecules of permanent dipoles have weak electrostatic force of attraction between delta positive and delta negative on neighboring molecules. The difference in electronegativity between two atoms in polar bond causes permanent dipole, and polar molecules have permanent dipole forces. Define dipole. Dipole is a difference in charge between two atoms caused by a shift in electron density in the bond, and charges in a nonpolar molecule, positive and negative charge, spread evenly across the molecule. What happens in a covalent bond between two atoms of different electronegativities? Bonded electrons pull towards the more electronegative atom. But for polar bond, atoms have equal electronegativities. Non-polar, therefore, electrons are equally attracted to both nuclei. 3 key characteristic of ionic compounds. Conduct electricity when molten/dissolved, not when solid. High melting points, giant ionic lattice held by strong electrostatic forces. Dissolving water, therefore water molecules are polar. This is easy, but you do need to know the key terms. That's why bonding is one of those topics from year 1 that I don't really like, because there's a lot of key terms you just need to know. Like, let me show you what I mean. Hopefully you guys are interested in this video. If you have made it this far in the video, thank you. So yeah, atomic structure, yeah, we know that's boring. Amount of substance, not really that many definitions you need to know, small calculations and titration practical. Bonding, look at that. And energetics, come on. Kinetics, equilibrium, redox, not that many. Periodicity, it's literally just one page. Group 2, group 7. And then obviously introduction to organic chemistry, a lot of definitions. This, you know, I would just do past paper questions for this topic. I wouldn't even memorize any definitions for this, or even go through the topic, because there's just no point. Like, so much useless information. Alkenes, alcohols, definitely you have to go through this. Organic analysis, again, these two are 100% from the year 1 topics you need to go through. Whereas these two, you could just, isomerism, maybe not, maybe you would have to know different types and all of that, but alkenes and halogen alkanes, you can just use past paper questions for that. So what does water molecules being frozen mean? It means polar molecules more positive, negative charge, polar molecules more positive charge, charged parts pull ions away from lattice, therefore dissolves. What happens when water freezes? Water molecules are not free to move, therefore hydrogen bonds form permanently. When liquid water cools to form ice, the molecules make more hydrogen bonds arranging into regular lattice structure. Molecules are further apart than molecules. Ice is less dense than liquid water. It is even on the specification. So if we go through the specification, ionic bonds, single covalent bonds, metallic bonds, 4 types of crystal structures, diamond, graphite, ice. Yes, ice is on the specification. Okay. But it doesn't ask you. Metallic bonding. Can't get away with that one. Metallic bonding, positive metal ions attract delocalized negative electrons, forming a lattice packed positive ions and C of delocalized electrons. 3 key characteristics of metals. Insoluble except liquid metals, strong metallic bonds. Delocalized electrons pass kinetic energy to metals, good thermal conductors. And metal, when you have to melt/boil a simple covalent compound, you only have to overcome the intermolecular forces that hold the molecules together. Very, very important. You don't have to break the covalent bonds. Solubility of substance in water depends on the type of substance particle contains. What is water? Water is a polar solvent. Substances that are charged dissolve well, and substances that are uncharged, non-polar, don't dissolve well. How are molecules held together? Molecules are held together by covalent bonds. And covalent bonds, single covalent bonds contain a shared pair of electrons. Giant covalent structures have a strong, huge network of covalent bonds. How can carbon atoms form giant covalent structures? Each carbon atom forms 4 covalent bonds. Yes, I'm going to get rid of that now. Because they would never ask you what do giant covalent structures have, and you obviously know strong covalent bonds. And carbon, you already know carbon can only form 4 atoms to it, so it can only form 4 covalent bonds. Let's get rid of that. Structure of graphite, you do need to know this. Weak bond between layers, sheets slide over each other. Others, Uses dry lubricant in pencils. Layers are quite far apart compared to length of covalent bonds, so low density. Used in tennis rackets. Insoluble in any solvent. Strong covalent bonds. Delocalized electrons free to move. Carry charge. Electric conductor. The likelihood of this coming up, 1% chance. Like describe structure of graphite, but could come up because it's on specification, so you do need to know it. Structure of diamond, vibrations travel easily through the stiff lattice, therefore it's good thermal conductor, insoluble in any solvent. Each carbon atom forms 4 carbons in a tetrahedral shape, covalent bonds. Dated covalent bonding, you do need to know the definition of it. Where both electrons come from one atom, and what a better way to know a definition, know an example as well. So you can, if you're given an exam question, where it's not only a definition, but you have to apply it, you already know an example. So where both electrons come from one atom, and the example is NH4 plus forming N in ammonia donates electrons to a H plus ion. How to use the number of electron pairs to predict the shape of molecule. Work out the central atom, work out the number of electrons in the outer shell of central atom, add 1 for every atom central atom is bonded to, divide by 2 to find the number of electron pairs on central atom. Positive metal ion is formed outermost shell of electrons of metals, delocalized electrons free to move. How the positive metal ion is formed. The number of delocalized electrons per atom affects the melting point. Again, I don't think that's on spec. So hydrogen bonding in ice, permanent dipole, induced dipole, van der Waals. But there's no. It does say metallic bonding, obviously, but it just wants to say attraction between delocalized electron and positive ions arranged in a lattice. No indication whatsoever of how the positive metal ion is formed, and a key fact about delocalized electron melting point. But I'm going to keep it because it is good videos. I'm going to keep it. The outermost shell of electrons is metal delocalized, electrons free to move. Number of delocalized electrons per atom affects the melting point. 3 types of angles between charge clouds, strongest to weakest. You do need to know this is on the spec. You know, it might seem like it's not, but it is. Lone pair angles are the biggest. Lone pair bonding pair angles are the second biggest. Bonding pair angles are the smallest. But I remember before I had definition flashcards of what define charge cloud. That's not in the specification. The 3 types: lone pair, bonding pair, and you have to know the strengths to weaknesses. The strongest to weakest. That's all you need to know. You don't need to know the definition of charge cloud and all of that. So definitely reduce these flashcards a lot, which is good for me.